computer science. The second month, the third month, the fourth month, the fifth month, we are going to do actual programming. Then the last month, which is the 6 months, we are going to do a project work, which each individual is going to do something based on what he or she has learned. And then we present at the end of the month, and we just, if during those periods, if you need any guidance, all the teachers will be available to guide you as in what you'll be doing. And since you'll be learning different languages or different programming languages, you will choose which one that you think you can do best in, so that you can do a small project. And at the end, we can assess you on those particular projects to see that we've made progress from that one. And we will know whether we should continue with the phase 2. That is the next 6 months, to also move on to learn something higher than what we've learned. Yes. So at the end of the 6 months, what we intend doing also, aside the project work, we'll be doing some small exams or some small quiz. But then after every session that we will be having, since we'll be having the sessions Mondays and Fridays, normally what we intend doing is we will use 1 hour for the whole tutoring and just the 30 minutes for questions and answers. So assuming today we have our session, Friday, the first 30 minutes is going to be the questions and answers. And even if there was any assignment given to us, we are going to answer all those questions within that 30 minutes. Then the next 1 hour will be used for the actual tutoring. So we should always get our books and pens or something. Just get a dedicated book that we will be using for your programming class. Anytime we come here, we will be doing let me do this now. I'm trying to do the recording so that we can put it on our YouTube page in case for those who couldn't join today. So that's what I've done. That's the introduction to the program outline. If you have any questions, you can ask us when you want to. So then when we come to actual programming, I know there are some senior members over here. I have James here, I have Georgetta here, I have Andy here. When it comes to programming or software engineering, let me use software engineering for that. I think that's the best term. We have the back end and we have front end. You'll be hearing these kind of terms. When you hear back end, something that works within the background that you don't actually see or you can touch. But for the front end is something that you can see, you can touch and feel. That's the front end. So normally we have people who normally do programming which is related to only backend stuff. So I'll be using WhatsApp, for instance. WhatsApp is an app that I think we all have it and we are familiar with it. The WhatsApp application that we are using, that's a mobile app. So we also have the mobile app aspect. And we also know websites, people who develop websites. Those people also, some are also front end, some are also back end. So let me use WhatsApp. WhatsApp has got the mobile app, and it has also got the WhatsApp web, which you can also do anything on your computer. So for the mobile app, people who design those particular apps are mobile app developers. So they will design the interface, they will design everything. But for the program or the app to be able to work, you need a backend guy. Those backend guys are the people. So let me use this for instance. When you type in a message and you send a message, for instance, it's not automatic that the message will be sent to the person that you are chatting with. The moment you type a message and you click on send, what the application does is it calls something called API. All these we will learn them later, but then I'm just introducing you to computer science. So APIs are application programming interface. What it does is those backend guys, what they do is they develop these particular APIs. It's like a gateway that you can pass through to be able to get to a computer which is sitting somewhere, which normally we call server. And these backend guys develop these APIs so that the mobile application will be able to use that particular API. And when you send a message or you click on the send button, this message will pass through this API. That's the gateway, or let's say a channel. It will pass through this particular channel and goes to a server. And these backend guys are the same people who will get a message that you send and now check who are you sending the message to. So they write all these instructions to the computer, and then the computer will interpret that, okay, fine, you are sending the message to this user A. So now they will now look for user A, his device. Where is it located? Is it located in Ghana, US, wherever? Then the application will now look for whoever you are sending the message to. It will now forward it to the person's device, and the person will see it, and it will now be tick blue. It will be done within like seconds. But then the number of instructions the program went through before it will be able to see the person you were sending a message to before it landed on his device, you have no idea. So it's like the mobile app will be there. So people who develop the mobile app needs backend guys before this whole application or software can work. So if you're a mobile guy or if you're a mobile developer and you develop only mobile app, the mobile app cannot live on its own. It needs to connect to a server for the server to also connect to other devices. So WhatsApp, when you send message, it goes to the server before it goes to the other person. And those people who develop the APIs for the mobile app to send the messages and interact with other devices, those people are called the backend people. So when you take when you come to website, for instance, websites, or when you go, no, everybody knows websites. So when you go to website, you open it on your machine, other things. The things you see over there, people who develop it are called the front end guys. So for the front end guys, you click on the button over there, you open this website, you see this one. Those are the people who develop all those things. So they are called the front end. Even for them, for you to even click on a button and to go and retrieve information for you to see, it also need a backend guy. So the backend guy normally is like an intermediate. He serves the front-end guys and he also serves the mobile guys with APIs. So the backend guy develop APIs and it will serve websites or any other on the computer. And it can also develop an API that can serve people using the mobile app. So that's how can we got the backend, the front end, and also mobile developers. Now, what we are expecting from you is we want you to be dedicated and also make sure you are serious with what we are doing. And also make sure you take this programming class very serious, because no one is going to tell you that the programming is simple. Programming is not that simple, but it needs a dedicated mind and also a dedicated tool to be able to achieve this.
Yeah, sure.
Is someone asking a question? Okay, so Dazi Eshuman, you can mute yourself and also can put off your video. Okay, so what do you need to start this course? This course, all what you need is your computer and your internet and your side book or the dedicated book for taking notes. But then later, what you'll be using mostly is your computer and your internet. So you need to have a constant internet and you just have your computer with you always. And what will you gain from learning programming? And it's fast. Programming over here, I will involve my seniors. Jajata is here, James is here, Andy is here, and I think who again? So they can chip in something. Why some of the importance that you can gain from learning programming? I think those people can, my seniors can chip in something here.
Hi everyone, good evening. My name is Andy. I think we are on course what Amankwa Senior Amankwa is saying is all on point. But to add more sugar to this whole project and propose training and sessions, programming is actually free. The whole project or the whole course is free. So don't let anyone deceive you that we are taking money or anything. We also want to contribute to the society, and we know computer science or computer engineers is one of the hot cake professions now in this era where we have COVID spreading worldwide. You can remotely sit somewhere and work abroad, and even be earning dollars, not even cedis. And aside that, you have your freedom. You work at your own pace. It depends on the company you will be working with or you associate with. But then when you look at the life of engineers, they live good, they live well. And our way of contributing to the society and the youth, we realize that most youth complete the university with programs that they've learned and they don't even get employed. But computer science, you don't even need certificates to gain unemployment. All you need is your skill and a proof of work. So if you have a proof of work that you've done something, maybe you've created this application, you've done that, you are qualified to get a job. And when you look at the job description, mostly they don't even require your bachelor's degree or anything. So we are on course. Take this serious, unless maybe you are already happy with your current profession that you are in. But if you really want to study and switch profession, this is one of the professions that is growing worldwide. And because of the COVID situation, everything is being automated, from banking sector to academic to health sector. Right now, they are reducing the number of tellers in bank and everything. So we are going more digital, more computerized, and we need more developers and more programmers to come up with solutions with tech. So take this serious. You might either be full stack. At the end of the day, you might be interested in all the various stacks that he said, or full stack. I mean, you will probably be in love with both mobile, front end, and back end. So we'll call you a full stack. Or you prefer just to be doing mobile work. It's good. All pays well. So just feel free, open up your mind. As much as we say it's difficult, it's not difficult. If normal human beings can understand, you can also understand. So just feel free, relax, and enjoy the class to the end. Make sure you don't miss any class. In case you miss, like we said, we are always going to record and put it on YouTube for you to have access. And try and make friends with people you feel you can easily communicate with. I mean, your own students, colleagues here who have maybe understood the concept better, and then you can ask questions from them. So this is the little I can share with you. I hope I've answered your question, boss.
Okay, great. Thank you. Jadata, do you have something to add?
Yeah. Good evening, guys. This is Jadata. I think I'm part of the tutors, so yeah, happy to meet you all here. Importance of programming. I think programming basically gives you a better lifestyle. Yeah, that's the main goal, and then the other one being helping you develop your problem solving skills. So once you're able to develop your problem solving skills through programming, and then you can now, it gives you the flexibility to do what you want to do in life. You don't need to be someone else's fiddle, be a servant all your life. I mean, you can set up your own company. You can start up. You can get a startup, set up your own company. With your programming that you learned. Once you're able to learn it well, you develop software yourself, and then you be your own boss. So that's the least I could say about programming. Yeah. So just take it serious and know that we are here to help you. I mean, let you know the little bit of what we've understand and worked with over the years, so that you can also better your life, or add on top of your life. If you want to change your careers or something, you can have a say in that. So yeah, that's it for me.
Okay, great. So you can take the last from James. We have James here, right?
Yeah, I'm here. Good evening, everyone. I'm James Adu, and I am part of the tutors for this program. My colleagues have said a lot about programming and software engineering in general. So many positives have been mentioned already. I would just like to add that initially it may seem difficult or something, but perseverance, you need that perseverance and that courage to push through, else you may give up along the way. But just know that it's achievable. There's so many people who have gone through this and they're making it big. So it's just a matter of time. Just keep pushing, and in the end you will get there. You'll get there. One thing I enjoy about being in this field is having control over my time. I don't have to work 8 to 5 or something. I can work anytime I want, and it's a privilege to have that. And if you're someone who wants to have that flexibility in your career, this may be a good thing for you to pursue. Yeah, so that's all I have to add to this whole thing. Thank you.
All right, thank you very much. We have Amos, but I think Amos left. We have other tutors who will also be joining. As and when they come, we will do the introduction. So let's quickly move on to actually wanted to do introduction of the students, so that you just let us know where your background, where you're coming from, and then we can do that later. At least your name and a little bit about your background or something. But we will do that later because of the time. We just have like 24 minutes. So at the end of this 6 months program, what we want to achieve, let me connect to the screen. Minutes. Okay, I've switched my screen. You can see my screen. You can see.
Yeah, I can.
Okay. So I don't know this is.
It says loading here.
Yeah.
Okay, so can you see my screen now?
Yeah.
Okay, cool. So I don't know this 6 months program, what we intend to achieve is to make sure at least we have some junior developers among us to be able to build an application to solve a real world problem through applying object-oriented programming concept. That's the main intention. And also they should be able to learn and develop some software applications based on feature requirements. So what we call feature requirement is a client will come, let's say I want an application that when you input 1, 2, 3, 4, it will just add all of the 1, 2, 3, 4 and just divide by 10. That is what I want the application to do. That's all. You know, normally we've got these farm milk and yogurt stores. They will tell you, I want this application that I can store my data over there so that when someone buys, let's say 1 farm milk, I will know that, okay, fine, it's left with 20 of them in my stock or something. So all these are feature requirements. So the client will tell you, I want this application, I want the application to do A, B, C, D. So we can give you a set of requirements and you can think through to develop an application to be able to solve that particular problem. So all these are termed as problems in the society that normally we think of to solve them. So let's start. Within the next 22 minutes, let's start and learn something so that we can build upon on Friday as well. So what is computer science at all? Computer science, we normally say computer science, but then it has two different terms, computer and also the science aspect of it. So we all know computers. Mobile phones are computers, like everything, anything that has the processor that's able to process, that's able to store data is called a computer. Even the calculator is a computer. It's because it's able to compute numbers. So computer science is just the study of that computers and also learning how those computers are able to compute as well. And also the theoretical aspect and the practical applications that we normally produce out of them. So that's basically the whole thing for computer science. And computer science applies the principles of mathematics. So if you know mathematics, it will be an advantage to you. But if you don't know mathematics, you will learn on the field. So that's not a big deal. So normally computer science is good for people who know a lot of mathematics, because mathematics, we normally apply a lot of mathematical problems. And most of the algorithms and the codes that we'll be starting with, they are more going to be in maths. So, but then I know I've mentioned two terms here, algorithm and pseudocode, but then we will explain them later. And also engineering and also logic. So logic is, let's say, you want to spell or you want to list a lot of, let's say, items over there. Someone can use, or let's say I want to go to Tema. Someone can say I will pass through Spintex road and go to Tema. Someone can say, okay, fine, I can take the shortest, I want the shortest route. I will take through, let's say, Dodowa to Tema. Someone can say, okay, fine. So all these are the logic people can apply to solve a problem. So, and the flow that you follow are normally called the algorithms. So that's the algorithm that I talk of. So algorithm can be the flow or the procedure you follow to solve a problem. And all these are under computer science that we are going to learn. We have artificial intelligence, we have hardware development, the software side out of it. So computer science also normally involves both computer, even every computer involves the hardware aspect and the software aspect. So we know that computer has a mouse, computer has a keyboard, computer has everything, but then let's do a little bit of programming over here. We'll come back to the computer science aspect of it. So let's say programming. Programming, what is programming? Programming at all is what is programming. So programming is like you writing a set of instructions. You know, computer don't think. Computer can't say anything. What computer does is it follows instructions. So computers cannot think like we human beings we think. But if you want a computer to think, that's the advanced form. That's what we have, the artificial intelligence. Even with that, they don't think. What they do is we give them a set of instructions for them to follow. So they learn from all those kind of instructions and they do something out of it. So, you know, even on your mobile phones, we have if it is an iPhone, it's where we have the Siri. And on Android, we have the Google, I think, Google Voice or something. You can talk to your Google using the Google Voice and they can give you a reply. On iPhone, I know iPhone is Siri, but Android is, I think, Google something. Google Voice or something. Yeah, you can talk to them and they can give you a reply as if you are talking to a human being. That one is under artificial intelligence because we've made them learn things about human beings and how human beings react to certain things. So the computer is acting like a human being now, but then we've given them a set of instructions to follow. That if you say this, they should answer you for this. If you do this, so they learn from it. And then they come up with giving you those particular answers. So programming is basically you writing a set of instructions to the computer for the computer to follow and execute that particular task that you want. So let's say an example is telling a computer to compute an average of 3 numbers. You know average. The reason why I said mathematics because average, when you say average is when you want to find average of numbers, an average is you adding all the numbers and divided by the total number of the numbers. So let's say we have these numbers here, 10, 45, and 32. You want the computer to compute or give you the output for the average of these three numbers. What you have to do is, you can't tell the computer to do this. You have to write the instructions for computer to follow. That the computer should follow these particular instructions so that it can give you the output that you want. So what you need to do is, you will need to give the instructions that, okay, fine, if someone enters these three numbers, what I want you to do is add these three numbers and divide by the number 3, and then give us the output, which is 29. So that is basically instruction I have given to the computer. But later we'll be learning how to write instructions. So that's just an example. Another example is telling the computer to print all alphabets from A to Z. If the alphabet is found in the name Ben, it should print the alphabet. Else, it should print none. So let's say I want the computer to print alphabet from A to Z. So it should be printing A, B, C, D, E, F, G. But then I want it to check against the name Ben. If the alphabet, if I take A and A is in Ben, I will print the A. But if it is A is not found in Ben, it should just print none. So I have to write instructions for the computer to follow to do this particular thing. So at the end, you see that the output will be like, A is not found in Ben, so to print none. B is found in Ben, so to print a B for me. C is not found in Ben, so to print none. D is not found in Ben, so to print none. E is found in Ben, so it will print E. And it goes on and goes and goes. So that's the instructions. So we come back to the hardware and the software part of it. So normally computers, we see the hardware, but the programs that run on the computers are called the software. So we have a lot of softwares. We have the Microsoft Excel, Microsoft Word, all those are softwares. So for the hardware is made up of a lot of components. We have the CPU, we have the memory, we have the hard disks, that are secondary storage devices, input devices, output devices. We just take a quick look at all those things. So we come to the CPU. The CPU is like, let's say, something that controls how a program should be able to execute. So assuming you've opened your Microsoft Word and you are doing something. For the Microsoft Word to be able to function well and to be able to execute what you want the Microsoft Word to do, is a CPU that controls the Microsoft Word. So when a computer is performing the task that the program tells it to do, we say the computer is running or executing the program. So it's a CPU that executes the program. So normally you will see that you have a computer and you have a lot of applications opened. You have your VLC open, you have this open, you have this open. And it is a CPU which will be running all these applications. So normally when your CPU, you have a very low CPU, or let's say a very low processor. Some have got the dual core, some have got Core i3, Core i5, Core i7, Core i9. And you will see that those that have got dual core, that is just only 2 CPUs. So these 2 CPUs will be running all these applications. You see the workload that you be giving to this particular 2 CPU. But if you have, let's say, Core i9, it means you have 9 of these processors, and they will divide all the tasks to them, and they will be running it. And you see, the workload to the 2 CPUs will be different from the workload to the 9 CPUs. So these 9 CPUs will be able to run the program efficiently more than the 2 CPU, because the 2 CPUs overloaded them. So normally, it's good you have computers that have like Core i5, Core i7, Core i9. So all these people, like, they have a lot of CPU, so they can run a lot of programs at the same time. So that's the central processing unit. So the CPU does all this. Now we go back to this. Let's say, so these are like fruits or food that you can have in your kitchen or something. You want to prepare all this at the same time. Now your mind is just one, and it's like it's going to process. Now I have this food, I have this, I have this, I have to prepare this, use this. But then if you have different people who are executing or who are preparing the food at the same time, you see that you'll be fast enough to be able to prepare the food, and it's like you will just finish just in time. But then if you are the only person and it is only one memory that you have, you can't do them at the same time. Yeah, you understand me? So these are like varieties of food that you need many people to work on. So the processor, if you got a lot of processors, it means your computer will be fast enough to be able to execute a lot of programs at the same time. So that's a CPU, for instance. But then if you are running your Microsoft Word, and you know Microsoft Word, for the Microsoft Word to be able to run, it needs to stay in a particular, let's say, area for the Microsoft Word to be able to run. So this side is called the memory. So the main memory of the computer is a work area. So you can't just say, I've opened Microsoft Word I'm working on. Before you open Microsoft Word, it has to be like, let's say, let me use let's say a room, for instance. You are going to do something, or you are going to iron your shirts, and that's a task you want to perform. Your memory will help you to iron the task, but then you need a space in your room to be able to put your things over there so that you can iron your shirts. So that particular space that you've laid your cloth, or you have the iron shed, that's the work area that you are going to work over there. And if you have a small room, and let's say you have a lot of applications running, or you have a lot of people coming to iron their shirts within the room, it means you are going to be choked within that particular room. So if you have a lot of space, you have a lot of memory. So some people have got like 4 gig memory, some have got 16 gig memory, some have got 32 gig memory. If you have a lot of memory, it means you have a lot of space to run a lot of application. That's to hold the data for that particular program that you're running at that particular instance, so that the application will be quick enough to respond to you. So at times you see that you click on an application and it's like the application is not responding, and it will wait for some time. The processor is running, the memory too is full, and it's like they don't have extra space to even do other things. So in programming, your processor is important, your memory too is important to be able to hold the data. Normally, that's why we say RAM is volatile. The reason why I say volatile is it holds the application that you're running at that particular instance. And whenever you switch off or you close the application, the memory is being cleared so that another application can come and occupy that particular space. So when you turn off your computer, normally the content of your RAM or your memory is also erased. And that's all. And now we go to the secondary storage. Normally we term them as the hard disks. So you know hard disks is just stored, it's a storage, and it's a type of memory that can hold data for long period of time. So for hard disks, if you store data there, can store them for like 1 year, 2 years, and you until you delete them. But for the memory, it stores the application that you're running, the data you are running on it, and everything over there. So even with this particular slide that I've opened, the data I'm using currently that you can see over here is being stored within the memory at this particular instance. If I close this one, this particular data that you are seeing here will be cleared from the memory so that another application can also use it. But for secondary storage, I can save this particular file in my storage, and it can be saved for like 10 years, 20 years to come. So that's the whole thing about this secondary storage. So that's the whole thing about the software and the hardware, and also a little bit about programming. But Friday will be very upon it. So now it's time for questions. And also, my senior members are here if they have something to add up. We have 7 minutes, so we can use that time for questions and also for any additions as well. Also, kindly let me know if I'm too fast in going through the slides, so that we can also know. We need to have feedback on that so that we will know how to do next time. Any questions? Okay, so James, you can also have your contributions to this particular session that we've had. The computer, that's the hardware, the software, and everything. Georgeta, if you have anything, you can add up. Andy, if you have anything, you can also add up. And by 8:30, our time, we need to close.
Hi, can you hear me? My power went off. Hello, can you hear me?
Yeah.
Okay. So to add to what my colleague said, the computer has many parts, just like the human body, and we comparing it to the human body, the flesh that you see, the physical aspect that you see is the hardware. The actions that goes on in the human body, and the energy that flows in the human body is the software. So basically, you will not see it. That's why they call it the software, and the hardware is what you see. Now, the software is what how do you call it? Are the applications that you can't touch, but then perform certain actions. So on your computer, you have an application that helps you to send emails, an application that helps you to see your bank account, an application that keeps record of certain data that you are performing. And that's what basically my colleague has explained, the software. And we are going to focus more on that side. We have people who are into the hardware section. They are into maybe changing or manufacturing the hardware, the physical computer that you see. And that's not what this subject is aimed at. So there are two main aspects of the main computer, and we are going to focus more on the software. And in software, we are going to dive into applications. Now, aside that, when he was explaining the CPU and the memory, for those who couldn't get it, let me just chip your mind back into it again. So he was saying, assuming you have about 50 food to prepare, you have a lot of orders, about 100 orders to prepare, and you are the only person to prepare. You are the CPU, you are the manpower of the application. Okay, so you are the manpower of the application. Now, assuming you have over 1,000 hands to do that food, within some few seconds, you'll be able to do it. But then when it comes to memory, memory is the storage where you are going to perform the action. So for instance, you have about 100 people who are ready to perform or cook the food, but then you have only one cooker, one utensil, and one spoon. Then everyone has to wait for one person to finish before the next person will come and do the cooking. So assuming you have a lot of memory in your computer, it means that you have a lot of utensils, a lot of cooking appliances around. So the job can be done within a few minutes because one is cooking jollof, the other one is doing apeprensa, and then the other one is doing owokple. At the end of the day, you do it within the same time and the food will be delivered on time. So basically, that's what he was saying. Now, it may sound so vague and so, okay, so what is all this about? We are giving you these basics so that when we dive into the programming aspect, you understand, you have the aha concept. Now, also feel free to ask all your questions, even before and after. For instance, after this whole session, you now didn't have any, you have some few questions, you can just put it on the WhatsApp page or anything, and someone can follow up and answer you. And also, you can also revisit this video on the YouTube channel and listen, and get what we are saying, because we are going to build upon this concept, and then we are going to build. So every session matters. So basically, that's what I'll add to what my colleague said. Over to you.
Okay, great. Thank you. So, any questions here? Are we okay? Or we are sleeping? All right, cool. So, thank you all for joining today's session. We will meet on Friday, same PM. It might be 7 o'clock, it might be 7:30, but I will communicate before we actually start the session. I'm going to share a link over here. Feel free to go through to grasp the main concepts over here under computer science and also programming. It's a book. Feel free to go through so that Friday we will start with actual programming, the introduction to programming, and we will take it from there. So I'm sharing a link over here. It's introduction to computer science and also to programming. Feel free, download it, go through, and let's have your questions coming. All right, thank you. All right, once again, good evening. Thank you. Bye.
Yeah, thanks, Marcus.